Alrighty, I just picked up from eBay a Berzerk board, and it is in awful shape. Lots of battery damage. I'm just kind of doing a documentation here of what it looks like. I just took it out of the box. Lots of battery damage. Crusted out ROMs. Crusted out chips. A super crusty Z80. Just garbage. And of course over here is not bad. A little rusty and crusty and nasty. But I'm going to bring this thing back to life. Because I've got Berzerk boards. I've got a RAM board and a color board that I know works. So I picked this up for like next to nothing. It came with another color board. And I think I did pay $40 for it. For this board. And this board. This one's pretty nice. But I've already got one of these that works, that I know works. That I repaired last year. But I'm gonna put together a whole new, another complete Berzerk board set. So that's what it looks like now. And this is after cleaning. Still a little bit here, but it's not bad. It's all neutralized. I got it really good with basically Lysol toilet bowl cleaner. It's got hydrochloric acid in it, a little bit, just a little amount of it. And that'll dissolve away a lot of that battery damage, and it'll neutralize it. So it won't do any more. I did it twice. Put it on there, let it soak for about 5 minutes or so. Take a toothbrush to it and kind of go over it. Rinse it, and then I did it again. So I did it twice. I pulled the sockets and everything off of it because they're junk. I pulled the black part of the socket off anyway. But this was well worth the $40 I paid for it. Because it is not bad at all. I have seen and brought back to life a lot worse than this. So cool. I got myself a Berzerk CPU board. And it's neutralized. The acid or the alkaline or whatever, the battery damage is all neutralized. So it's all good. It ain't going to get any worse. The back of it is super clean. It is not bad at all. Not bad at all. So, yeah. It's the beginnings anyway. The beginnings of this Berzerk repair. Okay. Okay guys, welcome back. I think it's time to get to this guy. I've got a complete Berzerk board set here. I put this up about a year ago. There are two boards that I know are good. The VFB, which is the big RAM board, is good, and the color board, the little color board, is good. Those are the only two I know are good. The CPU board is a mess. It was battery damaged, and I cleaned it up a year ago. I bought it on eBay, and I cleaned it up, and I put it away. It's been about a year now, so I think I'm gonna get to this and start working on this Berzerk set. And yeah, why not? So, yep. All right, let me unbox this thing and set it out on the table, and I'll be back. I'll give you a look at it. Okay, now as you can see, this guy right here, the CPU PCB is a mess. Yeah, the battery that was on it kind of leaked all over, and I cleaned it up as good as I can. This button's going to have to be replaced. Removed, replaced, whatever. It's stuck. But yeah, I'm going to have a lot of work to do on this guy. This board is good, as of a year ago or so. And this board is good. It also, in the box, I had a bunch of the connectors. So that's good. These are completely untested. Sound and speech. So first thing I'm going to have to do is work on this guy. And there's a lot of work to be done on this guy. So all the sockets need to be replaced. This guy's going to have to be removed. I don't know the condition of these things. But yeah, so I'm going to have to get to work on that guy. Okay, progress. Here's the junk out of the board. It's all the socket pins and the headers, the bus headers. They were looking nasty, so I'm going to replace those. That's these guys down here, the busing headers. And I got all the ROM sockets and the CPU socket and the RAM sockets all emptied out. All that. So I removed this guy, that reset button. I removed that because it was stuck. This one's okay. So next thing to do is repopulate. Okay, I'm going to start getting to this. I got my board all populated with sockets. And I'm going to start with this guy right here. Kind of try to put it center of there. Okay. And that's going to make it pretty much unseeable. So I might have to try to do this like this. Let me try this. So far, so good. Okay, you get the idea. So I'm going to go ahead and continue on. And all of the repopulating is complete. I got my new headers in. Some of them are different size, but it'll be fine. Brand new headers all along the bottom. Like I said, these ones are a little taller, but it's okay. All my sockets are in. So I'm going to go ahead and put a Z80 in it. I got to burn ROMs, put a couple RAMs in it. And I'll go ahead and hook the fluke up to this without any of the other part of the system on it and see if I can reach everything. Okay, I am hooked up to this. I've tested the power. Power is all good. Fluke is hooked up. I'm going to fire it up. Okay, do the setup. Alright, fluke is ready. Bus is good. And I got my cheat sheets for Berzerk. Last time I worked on Berzerk. So we'll go ahead and do our ROM checks. ROM 07FF A064. Okay. And it's not picking up that there's any ROM in that spot. So interesting. Okay. All right, so we got nothing there. So we'll go ROM at 1000 to 17FF. And that is D05D. And also shows that there's nothing in that spot. All right, and I'll probably get the same thing for this one. And this is E97C. What this is telling me is these aren't getting accessed at all. There is a decoding issue. Same thing? Yeah. See this 5CD7, that on a 2716 EEPROM, that signature is what you'll get back if there's nothing in the socket. If you just completely remove the ROM from the socket and the only thing that's coming back out of data is FF, that's what you'll get, I believe. It's either, yeah. If there's nothing in the socket, it's just reading FF back. So, yeah. Okay, well, I'm going to stop with the ROM checks because there's decoding errors. There's no decoding at all, basically. They're not getting selected. So I'll try the RAM. And the RAM on this board is 800 to BFF. Yeah. No decoding. Okay. I wonder if there's any clock on this board at all. Let's see if there's any kind of clock going on. Yeah. CPU clock. Okay. The test points here. IRQ address 15. Yeah, there is. There's a clock here. There's the CPU's clock right there. Okay. Yeah, there is just an absolute failure in the decoding section of this thing. So I'm going to have to stop and look at the schematic and what is the decoding, check the data buffer, all that good stuff. So let me do that. Let me stop, pull out the schematic, and I'm going to put a Z80 in here so this thing will try to run. I should hook the system up to troubleshoot it. Let me do that. Okay, I've got the system all hooked up, except for the sound and speech, which I don't need for this. But I got these boards hooked up, and what I think is going on is this thing, the power on reset circuitry is not working, as I think is what's going on. So I think what I'm going to do is I'm going to go ahead, there's like 3 or 4 transistors in here, and they're just simple common 3904, 3906. So I'm going to go ahead and just replace those guys and see if some of that battery leakage kind of crept up into them and damaged them inside. Yeah, and there's a Zener diode right here that looks like crap that I'll replace. And start with that and see what happens. Well, I replaced these 4 guys, the transistors, and I replaced this little Zener diode, and it didn't work. It was still stuck low and reset. So I just kind of probed around, and I found 2 bad traces in here, and I fixed those 2 traces, and it is now out of reset. So power on reset is now working, and my data lines all now have activity on them. They didn't before. It was just dead. It was stuck in reset. So now I can hook the fluke up to it and see if I can get to this stuff. So now that's what I'm going to do now. Is now that it's not stuck in reset, I'll see what I can do with the fluke. Before I go the route of the fluke, I'm going to hook the system back up, and I want to just probe around with my analyzer and look at some signals, some control signals and stuff like that. Just kind of make sure everything's looking decent. So it's going to get loud. I'm going to turn this thing on. Okay, so, and I want to do measure. Oh, gotta turn the system on, dummy. Okay. We are now on. I want to do auto measure. It's 2.5. 2.5 megahertz is what this is running at. Yep, and that's perfect. So our clocking is perfect. I got the schematic, big sheet schematic over to the right that I'm looking at. And the CPU clock, the main system clock, is 2.5 megahertz. And that's exactly what I got on my scope, so that is good. No problem at all there. I am getting a read-write signal, which is looking good. Addresses are looking good. stuck low. That's an issue. That's not right. Output number 9 is stuck low on this 08. 3A. This LS00 right here could be an issue. This is a NAND, not AND. Whatever AND. This is going to be 1. Okay, this is a 0. Yep. 0. It's floating. There's a floating output. That is definitely 1. 1. Yeah. That's not floating. It was floating. It looked like it was floating, but it's not. High. High. Signal will be buffering. No, because low. And it's at that end. And this seems like it's stuck high to me. If this were an and, it would be this and this. So it would never be high. Okay, so that's correct. If this were an and. You know, nothing confuses me more, and this is ridiculous. A simple NAND gate. I almost always have to write down the truth table to find out if it's working right. I get so flip-flopped with, you know, the AND is easy. They both have to be 1 to be 1. The NAND gates totally throw me off. Every time. And I sit and I try to play with my mind and be like, okay, if it's a NAND gate, it's the opposite of an AND, so they both have to be 0 to be 1. It's the only time it'll be 1 is when they're both 0. That's correct, right? The only time they'll be 1 is when they're both 0, because an AND gate, the only time it'll be 1 is when they're both 1. No, the NAND gate, the only time damn it, I'm gonna have to write down the truth table again, because I can't sort it out in my mind. It's ridiculous. Absolutely ridiculous. Okay, now I've got the simple truth table wrote out for a NAND gate. Now I can actually tell if this thing's working right. Stupid. Okay, we have a 0. Okay, A input is 0. B input is either 0 or 1. So the output should be stuck high. And it is. Okay, moving on. Okay. Next. What is... Okay, so there's a stuck... 3A is an AND gate. And that is a high input, and we have a low output. That is definitely no good. Okay, what is 4A? 4A is an LS20. Eesh. 4A is an LS20. Output is stuck high on LS20. It is a NAND. 1. This cannot be working. And that is a big time issue right there. 4A is an LS20, and the output on pin 6, I'm looking at the schematic, provides the enable for the memory selector right here, which is used to select the chip select on these guys. So no wonder I can't get to none of these. So high, good signal, low. There's a signal, but it's kind of clipped. And this one's always high as well. all have to be a 1 to be a 0. On a NAND gate, they all have to be 1 to be 0. Okay. And we have a stuck low there, which means looks good. What is pin 4 doing? Pin 4 is stuck low. IRQ. Oh, I think I found a bad chip. Let's look at this 367. This is the control buffer. I think this chip is bad from what I've seen. That's off the CPU. Okay, that looks good. Okay. That's a bad trace. It's got to be a bad trace. Pin 5, 6, 7, no, 6. Pin 6. Pin 6 is IRQ, which is pin 20 off of the Z80. That signal just looks like shit. Why does that look like shit like that? That's just being, you know what I want to do? I want to turn the game off, and I want to remove the Z80, and I want to float pin 20. I want to float pin 20 and look at it, because that signal should not look like shit like that. So let's float pin 20, and I want to look at pin 20 out of circuit. Son of a bitch. Okay, let's take a look. And it still looks like shit. Why does that look like shit like that? Okay. I guess it's just not an important thing right now. Not exactly 100% on how the Z80 works, but apparently that's supposed to be that way, so. Okay, back at it. All right. Okay. I don't like this chip. Okay. That looks good. That looks good. Pin 10 out to 9. What is pin 10? Pin 10 on that. Let's refresh. Which is always low. Refresh. 28, that should always be low. See, that don't make sense. Why is it always low? So I turned the system off. I'm going to float the refresh pin, which is 28. 21, 22, 23, 24, 25, 26, 27, 28. I'm going to go ahead and float that pin and see if it's always low out of circuit. Okay. It is. Okay. Well, let's turn it back off. And I'll put pin 28 back in circuit. I'm basically, if I'm seeing a CPU signal that is either stuck high or low, and it may just be that way, but I want to make sure that it's that way, because it's just kind of, I get it's like it's startup, but I'm just verifying that yes, that's supposed to be that way. You know what I'm saying? I don't know if that bent. Okay, continuing on. 4A I looked at. What is 5A? 4A? 5A is an O2. 5A is an LS02, which has its inputs backwards. The O2 is a NOR, not OR. This is another one of those where I'll probably have to write out the truth table. Not OR. If this were an OR, it would be stuck high. So it'll be stuck low, and it is. Okay. Which means, why is that never doing anything? Same thing. that chip is doing what it's supposed to. 6A. What is 6A? It's a simple 04. It's an LS04. It's just a high. So we got a low. Okay, signal there. Signal there. And garbage there. Garbage here. High. Okay, that looks like it's working. So far I have found one bad chip. This 08 is definitely bad. The 08. This is an 06, which... Okie dokie, I have replaced this guy. And I replaced this guy over here, the 08 and the 00, which was these two guys right down there, the 08 and 00, 3A and 7G. I replaced them both because either the output was bad or one was pulling it low, and I think that the 08 was just bad. But I just, two birds with one stone, I just replaced both of them. And that did fix that one leg, that signal, so that now I'm getting more stuff that's being active, and my game board is doing a little bit more now. So we're getting closer. So I started poking around a little bit, and I came to this signal. If you look at this guy right here, this is your ROM selector, 155 at 6E, and it's got a couple enable pins here, 2 and 4, 2 and 14, that come from 4A, this LS20. So let's probe pins 2 and 14 on that 155. 2 and 14. Right, here's the 155. Here's pin 2. And you can see, look at that. That's an enable line to our ROM selector. And remember, that comes from this guy. And this is an LS20. So we look at pin 1, pin 2, pin 4, pin 5. Those are our inputs, and that's our output. That is no good. That is no bueno. No bueno at all. So I am going to replace this LS20. I think the 155 is okay. I'm not going to replace that guy just yet. I'm just going to start with the 20 because I'm pretty sure the 20 is what... I'm pretty sure that is just a bad signal. Usually it's the stuck highs or stuck lows that make me question whether it's being pulled low or high by the other chip. When it's just a funky looking signal like that, it's usually just the chip that's outputting it. So we'll go ahead with the 20, replace that guy, and see what happens. Okie dokie, I have replaced the LS20 up here. And you can see our light is out and we're powered up. I'm back to this screen of nonsense. But the good news is I'm using this for reset. Watch the LED as I reset this. It is passing the initial first test, which I think is the ROM check, which is awesome. So it's passing one test. And I think the second test is the RAM test, to be honest. So I'm gonna have to, I'll verify that with the manual, and we'll poke around and see what we can see. Okay, I've decided to hook the fluke back up to it, and you can see I am good on my RAM, and I'm failing one ROM, this guy right here, and it's not the ROM itself, because I can put this in another location and it verifies. It's this spot on the board. There's a bad trace. It's got to be. So I'm going to shut it down, and I'm just going to probe out, beep out traces. Okay guys, I went ahead and I replaced this memory chip decoder, the 155, and I replaced the LS32 up here. And I'll turn it on and you'll see, watch the flashes. Now this board's passing all of its tests now. So it was one of these two guys. This one up here provided the direction signal for this, which I don't think was any kind of a problem. I think this was the problem right here. And I'll tell you something I also did is I removed this socket, and I just kind of probed around and tested around, and I didn't see anything funky with this at all. So I just soldered it back into the board. I think this guy right here was the problem. It might have even been this. I don't know. Some other gate in this thing that I don't remember if I saw something that was bad in there or not. I don't know. But anyway, I replaced those two guys. Now this board's good to go. So I'm going to go ahead and hook the rest of the system up to it, and this thing should run. So let's do that. Okay, I have the system hooked back up, and it is plugged in, and check that out. One of my all-time favorite games right here. This game is so cool. So all that's left to do is to check out the speech. Hook up the speech boards, and then I am going to make a connector to plug in my joystick, Atari joystick, and I'm going to play some Berzerk right here. Yeah, heck yeah. Look at that. So let's go ahead. I'm going to go ahead and hook up the speech boards and the sound and speech boards, and we'll see what we get. See if they work. Maybe we're lucky and the boards work. Alright guys, this is the complete Berzerk board set. You got your RAM board, your RAM and input-output board, color board, the CPU board, sound, and speech. And it is all wired up. Let's go ahead and fire it up and see if we got sound and speech. So far, so good. Heck yeah. I think I'm gonna have to wire in a controller port that'll plug in right here and solder it onto my connection. So I'm going to go ahead and do that. And then we'll come back and play some Berzerk. That way we can really thoroughly test all the sounds. Okay, I think we're ready to fire it up and see what happens. I got it all hooked up. I got my controller wired up. So let's fire it up. So far, so good. Okay. Sorry about the glare. We're gonna do the best we can, but put in a coin and start. Target. Oh yeah, sound good. Intruder alert. Intruder must not escape. Sounds great. Sorry about the glare. Intruder alert. Intruder alert. Chicken, fight like a robot. I got chickened. Intruder must not escape. Kill the intruder. Kill the destroy the intruder. The intruder must not escape. Pretty good escaping that. The humanoid must not escape. That guy right there will be. He's auto fodder. This game is awesome. Intruder, humanoid must not escape. Ah! Oh shit. Ah! close to the free guy. 5,000. I don't have the dip switches set right. Oh shoot.
Fight like a robot. Humanoid.
Jesus.
Intruder must not escape.
Oh, but he did. Oh, are you kidding me? Ooh. All right. Heck yeah. Okay. I'll bring you down here and show you what I got going on here. You can see here. This one is just a coin input. Kind of dangles. Coin and player one. This one is wired into the harness. So this one here is. It goes down to the edge connector. That's it. Berzerk. Pretty freaking cool. As always, guys, thanks for watching. I appreciate it. If you haven't subscribed yet, go ahead and subscribe to the channel. Hit the bell icon. You'll know when new stuff is out. I sure do appreciate it, everybody. Thanks for watching, and I will see you on the next one, okay? Have a good day.